Hi, Nikki, Tyler, and Janet. This is Monica, and I'm just checking in with what I learned about case studies. And I also looked at some information from place-based instruction because I thought that one looked kind of interesting. So here's what I learned. I'll start with case studies. I didn't really know how case studies were used in science. They've been used in law school and medical school, I guess, for many years. But it's essentially using a real or a simulated story to teach students about a field or something specific you want them to know about in a field. So I guess we could define case studies as stories with an educational format. You can set a case study up to where students have to find solutions to a real-world science problem. And a couple of resources that I found very helpful with case studies. One of them was the National Center for Case Study Teaching in Science. And if you go to Teaching Resources, and then you go to Publications, if I scroll down on the page, two of them that I thought were really excellent were What Makes a Good Case, and then up here, Case Studies in Science. When we're talking about what makes a good case, what's really going to get students into your lecture, what's going to energize your lecture, the authors suggest that your case study should be recent, it should be relevant, and it should be conflict-provoking, because those are all parts of a very good story. And I really liked how one of the authors of one of those publications described one of the benefits of using a case study is that students have to grapple with real-life, messy problems, and that's the way science is. Now, an instructor can really set up a case-based study however he or she wants. An instructor could be the sage on the stage and take students through a lecture, and there are case studies for which lectures work really well, and I'll show you one of those in a moment. Or the instructor can be the guide on the side and simply pose a question to students and then have them or help them to set up some method of working through the problem and then presenting their information in a discussion, a debate, a public hearing, a trial format. So there are lots of different options there, and so the instructor doesn't have to be the one doing all the talking. These publications right here, What Makes a Good Case, and again, Case Studies in Science, they offer up some ways that you can develop your own case studies, but I thought that seemed so overwhelming. Many sample case studies are available. For example, if we go back here, we're at the National Center for Case Study Teaching in Science. If you go right here, there was one on the first page. Let me find it. That was a really good one. Maybe I'll just go to Case Collection here. Case Collection, Farming in Space. This was a good one. And you can read a little bit about these case studies that they've provided for you. You can download the cases and then use them. This one requires students to develop a sustainable food supply on Mars. So they're given a problem statement. This instructor does a great job of outlining the different parts of the process that they're going to work through. Questions are provided, so that's really nice. You don't have to come up with those thought-provoking questions. They are provided for you. So that's just one example. You give the students this problem and you have them work through it. There are other examples of PowerPoints in which the teacher is presenting a lecture and in a PowerPoint format, and then periodically the instructor pauses and students have to answer questions about the case study at hand. So there are a lot of options for using case studies. This reminds me a lot of project-based learning, but unlike project-based learning, this is not a week or 2 week or 3 week time commitment in your classroom. You could take a case study and present it to students and have them work through it in a day or 2 days or 3, whatever you want. So it's a little less intimidating than project-based learning, and I could see using this in my classroom as a nice break from our regular routine, kind of re-energize maybe in between units or in the middle of a unit if I feel like kids' energy is dragging, because they like stories. All people do. So that's what I learned about case studies. The next one that I looked at was place-based instruction. And when I first looked at this term, I didn't really understand what it meant. And then when I looked into it more, it's inquiry-based learning. in which students are learning about something that's relevant to their local environment and designing solutions and researching. This made me think of Tyler's suggested project where he poses a question to his students about the pine beetle problem. What's the best way to solve the problem? That's relevant to their local environment. So if students see it as a real-world application, they should be more likely to enjoy it, and it should make them better scientists. But a couple of instructors decided to test this, set up some action research. So these two gentlemen, Gautreaux and Binns, their action research is there, and it's really good. I encourage you to look through it. But essentially what they did was they set up three different classrooms, 2 higher level achieving students, and then one classroom who was considered a lower level achieving students in there. And they offered traditional education to one of the higher achieving groups, and they offered a place-based instruction to the other high achieving group and to the low achieving group. And they posed a question about a local environmental concern. It was in Louisiana. It had to do with wetlands and logging and impacts on the environment. And it was really interesting because they not only tested these students with a pre- and post-test to see how much they learned, they also set a test up in a standardized testing format so they could see kind of if traditional or place-based instruction would help students on a standardized test. And they also researched student attitudes about science. And I didn't know this, but apparently student attitudes in science tend to decrease as the year goes on. Maybe I knew that and just didn't want to admit it. And so they developed a questionnaire to survey student attitudes. And their findings were mixed. They found that in the place-based classroom, student scores were really similar to the traditional classroom. So using place-based instruction didn't necessarily lead to an increase in achievement and attitudes, but it did not lead to a decrease either. So no harm is done by place-based instruction, and a person could probably argue that there was a lot of good done that maybe they weren't able to research or didn't measure. I found it really interesting, though, that when they looked at standardized test scores, they didn't really see a difference. And my personal opinion is that that kind of reinforces the idea that standardized testing is not necessarily a good indicator of what students are learning. So I have Dorn's ladder of usefulness here. And in Dorn's ladder of usefulness, I essentially rank things, or how useful I think they are. You can see penicillin is way at the top because it's incredibly useful. And way at the bottom, standardized testing comes in just above Donald Trump's hairpiece and decaffeinated coffee. That's my personal opinion, but that might explain why standardized test scores didn't deviate too much between the two groups. It might just be a flawed system for measuring. Interesting action research. I encourage you to read it. They did give some advice on how to make action research successful. First of all, students have to own the work. It really has to be their research. They have to come up with the questions, with the experiments, and if they don't, they're just going to see it as a set of directives handed down by the teacher. And this type of instruction must be scaffolded, meaning that it's higher inquiry level. It requires critical thinking, and so you can't just throw it at the students. You have to introduce them to this type of thinking piece by piece, and then they're more likely to be successful and not get overwhelmed. And something interesting the researchers found is that students will resist place-based instruction if it is not the norm, because since they had different control groups set up, some students doing traditional and some students doing this place-based research, students got to talking to each other, and they realized quickly that the students in the traditional classroom didn't have to do as much work. So there was some frustration in their school, and one student put on her final survey, "I would rather be bored and get an A than have to work hard and get a B." So that maybe tells us a little bit about what students are used to in science class, and that hopefully is an attitude that we want to get rid of, and maybe place-based instruction, if you make it the norm, if you make critical thinking and inquiry the norm, maybe we can erase that attitude. Very interesting action research. So there's my information about case studies and place-based instruction, and I hope you guys are doing well. Bye.